blower or fan? Engineers argue about it, catalogs contradict each other, and purchasing departments sometimes order the wrong machine because the two words got swapped in an email. The difference has a real technical definition, a looser everyday meaning, and a practical consequence for anyone specifying equipment. All three in the next few minutes. Start with the physics that both machines share. A fan and a blower both move air by adding energy to it with a rotating impeller. There is no hidden third mechanism. What differs is the balance between how much air is moved and how hard it is pushed, the ratio of flow to pressure. The formal definition draws the line at pressure ratio, the discharge pressure divided by the inlet pressure. Machinery standards put a device below roughly 1.1 in that ratio in the fan category, from 1.1 up to about 1.2 it is a blower, and beyond that it is a compressor. Those boundaries come from industry convention, and you will find slightly different cut points in different documents, but the latter is always the same: fan, blower, compressor, in order of how much the machine squeezes the air. Put in fan industry units, the numbers become vivid. A pressure ratio of 1.1 at atmospheric inlet is roughly 10 kilopascals, 10,000 pascals. The duct fans this series usually discusses work in hundreds of pascals. So by the strict definition, almost everything in ordinary ventilation, including machines everyone calls blowers, sits firmly in the fan category. The squirrel cage blower in a furnace is, formally, a fan. So why does everyone say blower anyway? Because everyday usage follows the job, not the ratio. The trade tends to say blower when the machine pushes air through a resisting system, a duct, a furnace heat exchanger, a bounce house, and fan when it moves air freely across a space, like a ceiling or pedestal fan. Usage also splits by geometry. Centrifugal machines get called blowers far more often than axial ones do. That habit contains real information. When someone asks for a blower, they are usually telling you the application has meaningful resistance, and that pressure capability matters more than sheer volume. When they ask for a fan, they usually mean volume matters and resistance is low. The word is a rough sketch of the duty point before anyone has written numbers down. But a sketch is not a specification, and this is where orders go wrong. A regenerative blower, a side-channel machine built for tens of kilopascals, is a completely different machine from a centrifugal duct blower at a few hundred pascals, yet both answer to blower. Order by word instead of by duty and you can be wrong by a factor of 50 in pressure. The word narrows the family, only numbers select the machine. There is one region where the distinction carries engineering weight rather than vocabulary weight. As pressure ratio climbs toward the blower range, air stops behaving as if it were incompressible. Density rises through the machine, the discharge air warms noticeably, and the simple fan laws this series uses start needing correction terms. High-pressure blowers are sized with compressibility in mind, ventilation fans are not, and do not need to be. Temperature is the practical face of that physics. Compressing air heats it, and a machine running at a genuine blower range pressure ratio discharges noticeably warm air even with perfect efficiency, plus the heat of its own losses. If your process cares about delivered air temperature, the pressure ratio quietly decides part of it. A quick tour of what the words mean on real products. HVAC duct fans, axial machines, plug fans, fan walls, fans, whatever anyone calls them. Furnace and appliance squirrel cages, blowers by custom, fans by ratio. Pneumatic conveying, pond aeration, vacuum applications, side-channel machines, blowers in the engineering sense too, often flirting with the compressor boundary. Nothing in ordinary building ventilation genuinely needs the compressibility mathematics. So how should you use the words? Freely in conversation, and never in a specification. When it is time to buy, translate the word back into what it was always hiding: the airflow you need, the pressure your system imposes, and which kind of pressure that figure is. Those three numbers make the fan versus blower question evaporate, because the machine that satisfies them is the machine, whatever the label on its catalog page says. If you are holding a requirement that says blower and you are not sure what it really needs, send us the duty behind the word, the flow, the resistance, and what the air is passing through. We will tell you whether it wants a duct fan at 300 pascals or a side channel machine at 30,000, and either way you will get numbers rather than nouns.